A method was developed to test grease hoods because the welded ductwork is encapsulated by 2-hour firewall. Fire codes would not allow the pitot tube traverses. ASHRAE Research Project 623. Testing grease hoods final report prepared by Elliot B. Gordon and Fuad Parvin. December 18, 1992. Principal Investigator Paul Droll, American Gas Association. The grease hood test was developed to establish airflow of a grease hood with a rotating vane anemometer because there was no other method. The method can be used on any hood with grease filters. Each filter must be read with a rotating vane anemometer in each corner and one in the center. The velocities are recorded and averaged. The following algorithm was developed to establish a correction factor K. K equals A1 multiplied by x1 squared plus A2 multiplied by x1 multiplied by x2 plus A3 multiplied by x2 squared plus A4 multiplied by x1 plus A5 multiplied by x2 plus A6 multiplied by x3 plus A7 multiplied by x4 plus A8 multiplied by x5 plus A9. The coefficient algorithm automatic calculation for K will occur after the following data has been recorded. The data is recorded as decimals and not fractions. The measurements are recorded using the inch-pound unit of measure. Hood length in inches. Hood filter bank length in inches. Hood filter height in inches. A actual overall area of filter bank in square feet. As the data for the hood filter bank length and the hood filter height are recorded, the area A, actual overall area of the filter bank, is automatically calculated. V, average face velocity in feet per minute, will be computed when all filter velocities are recorded. x1 equals average velocity divided by 100. x2 equals outward perpendicular distance of reading from filter in inches. x3 equals baffle filter slot spacing in inches. x4 equals baffle filter slot width in inches. x5 equals normalized overall area of filter bank opening in square feet. Design CFM taken from the hood submittal. Measure and record the hood length. Measure and record the hood filter bank length. Measure and record the hood filter height. A, actual overall area of filter bank, will automatically be computed when the hood filter height and length is recorded. V, average face velocity, will automatically be computed when all the filter velocities are recorded. x1 equals average velocity divided by 100 will be computed when all the filter readings are taken. x2 equals outward perpendicular distance, which is the distance the anemometer head is placed from the coil. x3 equals baffle filter slot spacing, which is the distance between baffles taken at their center line. The lower right-hand corner of the grease hood data form indicates x3 spacing. x4 equals baffle slot width, which is the distance between baffles taken at the edge of each baffle. The lower right-hand corner of the grease hood data form indicates x4 spacing. x5 equals normalized overall area of filter bank opening has already been computed and is shown at 5.90 square feet. The velocity readings are taken on each filter in 5 locations, with the vane anemometer flush with the filter. Each of the filter velocity readings were recorded in the columns on the grease hood data form in the following order. Row number 1, position lower left corner. Row number 2, position upper left corner. Row number 3, position center. Row number 4, position lower right corner. Row number 5, position upper right corner. After all the velocity readings are recorded, the average face velocity was 280 feet per minute. Average face velocity divided by 100 was 2.80. The K-factor was computed at 1.1009, and the actual CFM was computed at 2,810. A pitot tube traverse was taken at the grease cleanout. The duct dimensions were width 24 inches, height 12.5 inches. The duct area was 2.08 square feet. The velocity readings were calculated by taking the square root of the velocity pressure and multiplying by 4005. Velocity pressure 0.09, 0.11, 0.16, 0.19, 0.16, 0.11, 0.11, 0.1, 0.15, 0.16, 0.1, 0.08, 0.08, 0.12, 0.1. The average velocity 1,380 fpm times duct area 2.08 equals 2,870 CFM. The hood calculated 2,810 CFM divided by the Travers 2,870 CFM equals 97.9%. The grease hood readout is within 2.1% of the Travers CFM. The forms and the video shown will be provided to all AABC TBEs. The formulas have been protected. Depending on the brand of printer or printer settings, the form may add a line vertically or horizontally. Please do not adjust the margins. Simply drag the line to the blue border.